Welcome to this session. This session, we are going to solve a problem on projectile motion. The problem says, a particle is projected from a point with speed u meters per second at an angle of elevation alpha and moves freely under gravity. When the particle has moved a horizontal distance x, its height above the point of projection is y. So the first part, show that the vertical distance or the height is given by x tan alpha minus gx squared over 2u squared into 1 plus tan squared alpha. And then the other part, we have been given x information that a particle is projected from a point A on a horizontal plane with speed 28 meters per second at an angle of elevation alpha. The particle passes through a point B, which is at a horizontal distance of 32 meters from A and at a height of 8 meters above the plane. Find two possible values of alpha, giving you an answer to nearest degrees. So when we have such a problem, the first thing that you need to do is to draw a sketch so that you are able to fill in the given information. And from the sketch, you can get a bearing on how to solve the problem. So we have been told that the motion of the particle in such a way that its initial speed is u meters per second, and the angle of elevation of this speed is alpha. So this being a projectile motion, so we'll draw x and y axis, and then show the trajectory of motion of this projectile, and then identify this as our alpha, and these are the u or the initial speed. So the first thing after doing the sketch, let's now resolve the velocity of projection, both horizontally and vertically. So resolving velocity of projection horizontally and vertically. This I mean horizontal. So we write this one to mean horizontal will be from this diagram, the horizontal component of the velocity will be given by draw a right angle triangle here. Call this one ux, call this vertical one uy. So from Moshachota, we have this right angle triangle. So this angle is alpha, this one is u, and then this one you call it ux, and this one is uy. So sine is opposite of hypotenuse, cosine adjacent of hypotenuse, tan opposite of adjacent. So if you say cos alpha, cos adjacent, which is ux, over hypotenuse, which is u. So that tells you that ux, which is the horizontal component of the velocity, will be given by u cosine of alpha. Similarly, define sine of alpha, which will be uy opposite over hypotenuse, which is u. So this tells you that uy will be given by u sine alpha. So therefore, horizontal component of the velocity will be u sub x equals to u cosine of alpha. And then vertical component of the velocity will be given by, so we'll write this, illustrate vertical. So it will be u sub y equals to u sine of alpha. Now, remember, this is the x-axis, this is the y-axis, and this vertical axis. So if we concentrate on the x-axis, then along the horizontal axis, we know that distance is given by speed times time. So distance along the horizontal axis, if we call it x, will be given by speed. The horizontal component of speed of velocity horizontally is u cos of alpha times time, let's call it t. So then this tells us that x will be given by ut cos of alpha. Call this one equation 1. And remember, this is a projectile motion, and the only force which governs this motion is force of gravity. And this is how we model the force of gravity. So acceleration, when the particle, the motion is downward, it is positive g. And when it is moving upwards, it's negative g, because it's in the opposite direction of gravity. And because this particle is thrown upwards, so therefore the acceleration will be given by minus g. Now, when from this equation 1, from equation 1, we have t alone will be given by x over u cos alpha. X over u cos alpha. So I want us to call this one 2. Now let's go to vertical. Vertical, also we say distance, actually the same as height, is given by speed, or we know the distance formula from equations of linear motion. So we know that distance is given by ut plus a half at squared. This equation, we know it from the discussion on equation of motion of particles moving in a straight line. So a t squared. Then, because we are concentrating on the vertical, so we call it y, will be given by u y times t plus a half. And because the projectile is moving upwards against gravity, so this will be negative g, and then t squared. We have calculated that our uy is u sine of alpha. So we multiply by this t, we'll have ut sine alpha, and then minus a half g, and then t squared. So call this one equation 3. Now what we are going to do, we are going to replace where there's t in this equation 3 by x over u cos of alpha. So substituting 2 in 3, we have y equals to u Where there's t, you put x over u cos alpha times sine of alpha minus a half g into this t replaced by x over u cosine of alpha, and then you square. So this will give us y. Now, this times this one here will give us this, and this cancels out. So we'll have x and then sine of alpha over cos of alpha minus, so we'll have a half g x squared over u squared cos squared alpha, because this square is affecting everything here. So you can show that this and this have crossed out. So we'll have y. Remember, sine over cos is tan, so the x tan alpha minus a half g. I can put this u squared here, and then x squared 1 over cos squared alpha. Here the same term. But we know that cos squared alpha plus sine squared alpha is 1. So when you divide through by cos squared alpha, then we'll have cos squared alpha over cos squared alpha plus sine squared alpha over cos squared alpha equals to 1 over cos squared alpha. So which means that 1 over cos squared alpha is the same as, so here we get 1. Sine over cosine is tan, but then square. So that's what we have. So which means that in this equation here, where this, or in this equation, this lower equation here, where there's 1 over cos squared alpha, then we can always replace that one by 1 plus tan squared alpha. So from this equation here, so that we'll have y equals to x tan alpha minus gx squared over 2 u squared into, so this will be 1 plus tan squared alpha. And that is what we were supposed to prove, that y is given by x tan alpha minus gx squared over 2 u squared into 1 plus tan squared alpha. Now the second part, we were told that the particle is projected from a point A on a horizontal plane with a speed of 28 meters per second. So this is our u at an angle of elevation of alpha. The particle passes through a point B, which is at a horizontal distance of 32. So the x is 32 from a point A at a height of 8 meters above the plane. So the height, which is our y, is 8. So to find the values of alpha, we simply replace u for 28, x for 32, and y for 8 in this equation, and then solve the resulting equation in terms of alpha. So we say here, y is given as 8, x is 32, g we know is 9.8, and then u is given by 28. 8. So that's the information we have. So this is part B. So replacing these values in the equation, we'll have 8 equals to 32 tan of alpha minus G is 9.8 times 32 squared divided by 2 U is 28 squared into 1 plus tan squared alpha. So let's simplify this. So we'll have 8 equals to 32. Actually, to make our life easier, we can fix tan alpha to be a given letter. So you can just say for convenience, let T be tan alpha. So that we'll have from this 8 equals to 32 T minus, so 9.8 times 32 squared divided by 2 times 28 squared. So we have 5 over 32 over 5. That's 2 over 5 into 1 plus, so tan squared alpha will be T squared. So we multiply every term by 5 so that we have 40 equals to 5 times 32 is 160 T minus 32 into 1 plus T squared, which implies that 40 equals to 160 T minus 32 minus 32T squared. So take every term to the left. So we'll have 32T squared minus 160T plus this one will give us 72 equal to 0. And then 4 can divide every term in this equation, or even 8. So dividing through by 8, divide this by 8, divide this by 8, divide this by 8, divide this by 8. So before T squared minus 20T plus 9 equals to 0. Then we use quadratic formula. T will be minus b plus or minus square root b squared minus 4ac over 2a, where our a is 4, our b is minus 20, and c is 9. So we'll have t equals to minus b will be 20 plus or minus b squared 400 minus 4ac. So 4 times 9, that's 144, divided by 2a, so that will be 8. So 20 plus or minus 400 minus 144, 256 over 8. So t equals to 20 plus or minus square root of 256 is 16 divided by 8. So it tells us that t equals to 20 plus 16 over 8, or t equals to 20 minus 16 over 8. So 20 plus 16 divide 8, is 9/2, which is 4.5. And then this other one would be 20 minus 16 divided by 8 is 0.5. But remember, t is tan alpha. So which tells us that tan of alpha equals to 4.5, or tan of alpha equals to 0.5. This one means alpha is arctan or tan inverse of 4.5. This one means alpha is arctan or tan inverse of 0.5. So tan inverse of 4.5 is 77.47119229 degrees. So roughly 77 degrees because it was to nearest degrees. And then the other one will be tan inverse of 0.5, which is 26.565051118 degrees. So this one is 27 degrees because they wanted us to express our answer to nearest degrees. So those are the two values of alpha required in that problem. So you can actually just sketch. So the sketch of those two values of alpha will have these two kinds of graphs. One for angle of 77 degrees, another one for angle of 27 degrees. So the one for 77 degrees will have a steep, and then the other one for 27 will be, we'll assume this shape. So this is 27 degrees, while the other one is for 77 degrees. So that is what that problem required. Thank you.